Hello everyone, welcome back to our live. So we are here to practice the live stream. So let's just check me. Is our live session is working properly or not? Just let me check for a few seconds. So till then, let's give you a little brief about what we are doing. We are currently practicing JavaScript, and in that we are practicing system design questions. The system design questions, we are here into the level 3 and continuing with the last session question. Let's check the audio check now. Yeah, it's audible. Let's see. Starting our sessions. Make sure the voice is audible and we are good to go live. Okay. Now let's start with the question. So today's question is the level 3 question, which is about AI history mode. Okay, that's a great. The pub/sub message broker event driven architecture. Okay, we are seeing the event driven architecture example. The problem in microservices should not be tightly coupled. If any order is placed, the order service shouldn't call the shipping service, mail, email service, and inventory service directly. Instead, it publish an order placed center event to a central message broker like Kafka or RabbitMQ. Okay, they are the popular thing that we know in industry. Any service that care about orders simply subscribe to that event channel and reacts independently. Okay, little understanding. In the microservices, services should be tightly coupled. If any order is placed, the order service shouldn't call the shipping service, email service, and inventory service directly. Okay. So whenever an order placed, like you are ordering some phone on Flipkart, so you are order something, so it sends the request. So that request shouldn't be directly accessible by email and other things. Instead of that, it will be calling a central broker like Kafka or a RabbitMQ or any other central broker. So in the central message broker, it will be called, and through there the process will be distributed and further going on. Okay, so that's the our understanding. So let's go forward. The task build asynchronous event driven message broker class. Okay, the requirement is a public state, which means a topic, object mapping channel names to array or a callback function. Okay, and object mapping channel names. Okay, here it is something new. Also, we have to create a private method, public methods like subscribe and async publish. How to proceed? Let's build the entire. Okay, this was the other thing. This is the main question. Let's follow it. Create a class. We have a class name. Does we have a class name? Yeah, we have a message broker. Message broker. Okay, message broker we have been created. In that, let's create a constructor first of all. Okay, here we have created a constructor. After that, we have a topics private variable, object mapping channels names into the array or a callback function. Hmm, object mapping channel names to array of a callback function. uh, a little bit confusing. Just understand what does this mean. Actually, I'm not getting about. Explain me what does this means. Okay. What, uh, okay. Let's just a second. So what does this means? It's connect a channel name like a room or a topic to a list or actions, a code block that should run something happens to okay, just a second. Mm, I didn't getting it. Okay. Let's in the okay. Is our life is properly visible? Yeah, it's visible. Real world channel name, sport updates. Okay. It's object like okay, like this we have to execute. Okay, how the code just work? Think object like this. So we got a glimpse of out what we have to do. Okay. So let's move forward and object mapping channels name into the array. Channel names into the array. Okay. Topics. Let's create as an object. We have created an object for now. Let's see, does it have a constructor? No, no constructor. We have a public method, subscribe. So this is a system design question that we are practicing. So let's create a subject which has a method, which has a subject name, topic name, and a callback. Okay. Add a consumer callback function to specify topic list. Actually, reading this thing, it's a little bit hard to understand what we have to create. But in the interview, like we will be having this kind of a question, so we have to be prepared for that situation. So we are practicing now. Okay. Also, we have another question. Another method is async publish, and in that we have a topic name, comma data. So what I need to do is topic name will be it's like here, and it's should be maintaining this object. Inside that we are maintaining like this thing weather equals to action and action 2 news equals to action 3 like this we have to pass an array. Okay. So how should we do this? An object mapping channel names to array of a callback function. What is aside from this we have mm, subscribe topic, add a consumer callback function. Okay, add a consumer add a consumer callback function. Callback function is a consumer to specific. Okay, which means we have to create a consumer callback function. So here we have a consumer, and here we are calling it. Where else the consumer has been working here? Okay, for now let's leave it that. Async publish topic name. Uh, Topic name and the data. Loop through all registered callbacks for the specific topic and executed them asynchronously, passing the data overloaded to each listener. Uh, it's a little bit more confusing because like this we didn't understand the question also. New thread, what this is the new thread? Okay, no, the not new thread. We need the same thing. The problem is in the microservice should not be tightly coupled. If any order is placed, the order service shouldn't call the shipping service, email service, inventory service. Okay, there are three kind of a service. We go okay, understand. Instead of a publish and a order place event to a central message broker like Kafka. Uh, let's take a goal decoupling massive distributed software tracking pipeline clearly. We have to create a pipeline, okay, but how should we create that? Mm, mm, Build a synchronous event driven message broker. Publish, subscribe. We have a topics. In that topics we have to maintain some kind of data, but how? The question is about how. Do you have any idea related to this? So share your ideas in comment section. We will love to say that. But let's be little think more wisely and deeply what we have to do. Asynchronous event driven message broker. Okay. Classes we have been created. It has a topics. Okay. Object mapping the channel names to array of a callback function. Object mapping channels, channel name, and the object is mapping, okay, channel names to an array, to arrays of a callback function, to arrays of a callback functions. Let's just understand what does this mean. So how does work? How how does this works? Let's just check and understand. Empty event, okay, we have a same like this function. If event dot registry channel name, if event dot registry channel name does it have, then channel name equals to, oh, got it. So it's work like this, channel name, which is, yeah, got it. uh okay, so we have taken the help here. So what we are going to do is, if we will be see, if it the channel name, which means topic name, if it the topics, event registry is our topics, right? If topics dot topic name, if a topic name is not there, okay, topic names is not there, which means a true conditions, then what we have to do, topics and topic name equals to, we have created an array, and if it is there, which means we have to just add it, topics dot topic name, in that object we have to just push the call back, okay. So these are the critical things. Actually, we didn't know how to think like this also. So in here, system design, we are practicing and creating a mindset of a development, how we can analyze and understand and develop such kind of a critical thinking about the coding and system design. Okay. So I think so we have been completed this part. What about the second part? Second part is about adds a consumer callback functions to, yeah, so this is a consumer callback function that it's working through loops all register callbacks for the specific topic and execute them asynchronous, passing the data payload to each listener. Still it's confusing. Loops through all the register callbacks, loops through all the registered callbacks and execute them asynchronously, passing the data payload to each listener. Each listener uh, didn't got it. Here we just misses the this dot hashtag topic, because that is a private variable, right? This dot hashtag topics, this dot hashtag topics, this dot hashtag topics. Again here, this dot hashtag topic name. Oh, no. It's didn't related the topic name. It just related for the topics. Okay. This dot hashtag topics. But we still now didn't understand this thing. What does this mean? Explain me in ELI5 about this context. Let's understand how it's working. Imagine you are a school teacher with a magical clipboard. On this clipboard, you have a list of topics. Under each topics, you have a list of students who want to know about it. Here is how that a sentence works in a 4 simple steps. When something happens, loop through all register callbacks. What does this mean? Registered callbacks. We didn't registered, I think so. Uh, okay, by the callback, which means this. Okay, okay, okay. Got it, got it, got it, got it. Understood. We have this thing, and this has a callback either. It has a function like this. So this thing is going to happen. So we have to check the callbacks, which means this is a thing, and we are getting a data and a topic name, which means this. We have to check with this function callback. When something happening, let's check a package arrives from the topic art for class. Look at the clipboard, run the finger down and list of the students callback who signed up for the art classes. You check every single name one by one, okay, for that specific topic, okay. Uh, 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 a little bit understood. Let's try with this. We have to check, okay. Uh, It's in short, what is it? The system looks at the sign up sheet for a specific event, grabs everyone who signed up, hands them a new information, and tells them to start working with the same exact line, exact same time mm, for the specific topic, and executes them asynchronously. Instead of calling one student to a desk, waiting for them to finish and calling, you can fast away telling you yell out their names at Alex, Sam, Taylor, go out your work. Oh. Okay, okay, okay. So we have figured out the subscribe thing in our system design question, and this is a level 3 question, which is interesting quite. So what we will be do is here we will be asked first of all the test case is this dot hashtag topics and name. If it is false, topic name is it is false, then return not topic not find, topic not find, okay. So we will be return with this. Else we will be do is this dot hashtag topic name. Topic name, it has a callback, right? mm, Suppose it has a function callback functions of a array, so we have to call it, right? Topics name, topic name by topic. uh, Let me see. Topic name is the array, and array will in that array inside that we have all the thing, right? So we will be calling is topic name. We got certain thing. We will getting a array, okay. So what we will be getting here here this we will be is equals to is the array. So that let's array equals to this, and what we will be do is array dot for each, and inside that let's do certain kind of thing. We have done the for each, and we will got here item and idx, okay. So we will play with the uh, item and call it passing with data, okay. um, do we go with the for each, or let's go with the await here, await and item dot pass. Yeah, we concluded correctly, I think so. Item dot data, we have a item is a function, right? Callback, and in the callback we will be just returning the data, the data will be returned, okay. So what else we have to do? Okay. Got it. Give me a test cases for this. Generate generate some test cases to check my code for this question. Okay, so we have been generating some test cases. Let's just see. Multi-consumer broadcast. Okay, delay second. Okay, so this is a huge test case. Let's run this. Hmm, let's just check. New message broker. Okay, inside here. Let's run this. Await is only valid async function. Okay, so let's go for loop here. Let I equals to 0, I less than this dot less than, I think, array dot length and I plus plus. Okay, after that just go for this uh, array of array of I equals to data dot pass. We have been passed the data. So for now let's remove the thing. Okay, and let's now this dot topic name must be declared. Okay, we have been spelling mistake 26. Topics name. Do we have a topic name? Okay, so this dot topics. Okay, yeah, it's a fair enough. Step one, register successfully, publishing. Okay, so what does this output is about? Conferring, configuring distributed subscribers, register success, publishing primary transaction date, event, order service, email service, dispatching, email client, manage address system.io. Okay, yeah, let's just check. I think so. This is the correct solutions that we haven't provided here. Let's give a feedback from this. Okay. So this is our solution. Review this and give feedback. So let's just check our solution by the array. System verdict product. Oh, 9.5. So certain 0.5% we have a flaw. We are learning. Okay, also I've taken the help of the Google also, because I didn't know about this, what does this sentence means and what does, so get to know about the more thing about here in the system design, because these are the certain things that we perform in production level. So but we didn't know what we call. Okay, your verdict production grade architecture, your implementation message broker is excellent, your standard initialization logic, subscribe, publish. Okay, okay. Sequential bottleneck. Okay, so here the sequential bottleneck can be occur. Why it is bottleneck? By placing the await keyword directly inside a standard for loop, you are executing your microservice sequentially one after another instead of parallel concurrency. Okay, we have to do a parallel concurrency. If the email service takes 2 seconds to finish, the your loop completes, pauses, and okay, okay. So what we can do is let's compare with our, okay, so if the topic no the return topic not found, that is right, we have to use the callbacks. Okay, this dot they are using as a callback. Okay, so it is a constant, so we are calling array, so they are working is like this. Oh, they use the map thing. Okay, so we can also use that thing. So what we will do is const process equals to we have a array dot map for better understanding, and here we have like this structure. Okay, so here for simplicity I'm using the simple words that we are using, item. Okay, and it will be just working as a try and catch. Okay, and that we are getting an error, and it will be console.log console.error, and this is the error, and here we got error. Okay, so this is the thing, and here we will be doing await call, not callback, array comma data. After that we will be uh, doing the await promise dot all what we got process will have a final data inside it, right? And here we pass it all. So now it will be working as a parallel, not one after. Okay. Why it is wrong here? Okay, because we didn't put the async. So okay, it's not an issue while we call here. Error array is not defined a function, not a function. Okay, we got two error. Right, so mm, what is wrong actually? Okay, because here it's a CV callback and callback we are calling, and in that we are passing the data. Now it's working fine. Okay, so okay, in that case we have been seeing also the error thing because we didn't know how the error case will be working. So yeah, these are the system design question. This actually a little bit confusing how it's working and fine. Let's just understand this test cases. How does this work here? Cons delay ms new promise resolve set timeout resolve ms. Okay. Function run message broke tests. Initial are decoupled events broke engine cons broker new message broker. Okay. Step one configure distributed subscribers. Mm-hmm. Okay. Okay, understood. Let's move forward with the further such questions. Ready to real world officially build a foundation, advanced foundation, object-oriented programming, memory, prototypes, asynchronous timelines, and high throw inputs architecture. Okay, real world, real time engine, ready style mock, database class with a safe, stale configuration expiration timers, TTL, snapshot, and transaction rollback. Uh, 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 Okay, they are the interesting thing. So through far what we have been practiced, it will be used together in this event, e-commerce event orchestra or orchestra or something like that. Comment orchestra. Yeah, decoupled. Okay, here we will having our load balancer circuit, message broker into single unified applications. Okay. So in the next session, we will be starting with such kinds of problem statement. Till before that, let's have a quick small things that we can practice. Okay. So we will start with the above describe projects, mini projects. Before that, give me a single mini project in which we can upskill so far journey, and then we will move forward with this this projects. Okay, let's have a glimpse about the thing. To bridge gap between your conceptual knowledge and full-scale system architecture, let's tackle a single cohesive project first. We build a resilient distributed task schedule engineer. Okay, so these are the wordings which actually what we say difficult some kind of. Let's see a single project. The single project combines every single pillar pattern mechanism you have mastered so far. Oops, prototypes, asynchronous timelines, and rate limiting, resource management, and fault tolerance. Okay, so we will be understand this blueprint, resilient task reschedule engine. Imagine you are designing the background worker engine for a system like AWS Lambda or a distributed task runner like Celery. Your engine must ingest a queue of asynchronous tasks, process them concurrently, respect resource limit automatically, retry network drops using potential backup, and drop tasks cleanly if they fail permanently. Okay. uh, Incoming task. But you also have to understand how they are that calling their architectural requirement, how they are understanding what is the need, because someone needs to planning, right? So how they are planning, like this we are need and how we can create. So we are in the small step, initial step. So we need to understand by their instructions only for now. After that, we will be able to create our own instruction and follow them. Okay, let's create this the prototype blueprint resilient task. Okay, instead of modern classes construct using this component using old school constructor function and prototype chaining. Okay, so let's create using old style. So we have a function which called resilient task, and in that we have a task name and API call back. Also max retries. Okay. Here we have this dot task name equals to task name, this dot API call back equals to API call back, this dot max retries equals to max retries. Okay, so we are having this thing. So this is the old constructor function thing. Set an instance tracker for name, callback, and max retries. Okay, and attempt count start from. Okay, this dot attempt count equals to 0. Then prototype method. We have to create a prototype method. So resilient task dot prototype dot uh, what we have to call execute. So like this we are creating a prototype. Okay, so it has a function here. Okay, so what it is about, this must run the callback using async await inside a try catch. Okay, let's create a try catch block. Okay. That we have to, here it will be console dot error equals to error, and here it will be, see, either it's a async, and here it's a await. What will be await? If it fails, it must increase the attempt count if it is hit. Okay, this runs the callback using async await. Okay, attach the execute to the recyclance. Okay, got it. Now we have a callback, right? This functions, this must run this must run the callback using, does it mean by API callback or certain different callback? For assume, let's here we will be getting a callback and it will be called this. Okay, so let's just forward. So this is the system design question that we are practicing for now, creating a resilient distribute task scheduler engine. So this is a combinations of what we have been learned till now. The oops concept, the asynchronous, the constructor functions, old way of a ES5 version of a JavaScript. So all this combination we are practicing together in this question. Okay. So if it fails, it must increment the attempt count. Okay. So first of all, if it fails, which means error, so it must attempt the count. So this dot attempt count equals to plus equals to 1. Okay. Uh, if it hasn't hit max tries, it must calculate the exponential delay. Okay, so here it's coming the things more confusing to us, and we have to understand how these things are working. Okay, let's analyze the thing. Little bit more confusing. So how the level is increasing, it's actually more confusing to us. So yeah, because the level has increased and we have to increase our level too. So we have to practice more and more difficult sum so that we increase our mental capacity and perform the questions. If it fails, it must increment the attempt count. Okay, attempt count. If it hasn't hit the max retries, it must calculate an exponential. So how this will be? Suppose it failed here, which means it will become down, right? So we will be either here doing the this count, and here we will be doing if it is fail. Uh, Here the console.log error will be print, right? So let's give the this priorities here only. If it is fail, then the attempt is okay plus after console, and we will be check here. We will be going to check if it hasn't hit max retries, which means if this dot max retry is, if it hasn't, which means not, if not equals to this dot attempt count is not equals to attempt count, it must calculate an exponential delay. How do we calculate the exponential delay here? Of 2 multiplied by attempt count. Mm-mm. Log the back of warning, exclude, execute a blocking sleep and recursive call. This dot execute again. Mm-mm. Yeah, this is actually so much confusing. Let's go with line by line. If it fails, because which means here if it fails, then what we have to do? Must increase the count. Increase the count, done. If it hasn't hit the max retries, this dot max retries not equals to attempt dot count. If it is true, then what we have to do? It calculates the exponential delay, which means exponential delay how we calculated it. This means max dot, which will be max dot power is 2 comma this dot attempt count. Okay, so this will be max dot power. Okay, powers value answer we getting out. Okay, log the back of warning. Back of warning, where is the back of warning, man? Log of warning, back of warning. Okay, uh first let ans equals to, yeah, like this. After that what we have to do is console.log back of warning. Little bit still confused how it's going to work. Execute a blocking sleep. Execute, and after that blocking sleep, that recovery call. Okay, and okay, let's console.log. What do I understand is like this. And after that, what we have to do is execute again. Resilient task dot prototype dot execute call. We have been called again. Okay. Um. So far, my good understanding, I think this is, but mm, a little bit confused also. Attempt count is 3 something, 1 to 2 into 1 2. So it should have a ms also, right? Let's create a const ms. See ms equals to, does it ms? Yeah, ms, create a ms callback. Ms equals to mm, function. Okay, function. It's a function, and here it's a return new promise. In that promise, we are passing, what we are passing is uh, wait. Okay, so here call the wait function, and here we have a ms, and this ms will be passed here. Set timeout. Okay, set timeout has two things. It's about the ms, and it's here will be working console.log loading. Yeah, so here you have wait. Mm-mm. Okay, not resolve. We have a resolve and reject here, right? And it will not be the like this. Let's resolve uh, comma ms. Yeah, it's a little bit difficult to understand for me. Resolve ms. Okay. Loading here. So this is the better format for us to understand. Okay. So we just wait. Wait, and we pass the and here ens here, ens here, and it will be asynchronous, I think so. So what is the nearby calling function? mm, yeah, it's fine, I think so, right? Yeah, it's pretty good for here. So we executed this thing for now. Let's move forward with the next question, which is, and after that which will be execute again, right? So it will be execute again if it is less than. So for better knowledge, we have been done with this, and let's move forward with the second question. I think second thing, there also they have a wait ms, that they are also doing the harness thing. Uh, 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 yeah. But before that we have to do this thing. mm, Task scheduler, they are also working with a task scheduler. Build a layer using a modern JavaScript class with private field to ensure the complete state isolation. Okay. Let's go with this. It has a task, schedule, task scheduler class, where we have a constructor. Okay, here we have a private state, hashtag max current slots. Private state, this is the concurrent slots. This hardware is the okay resource. Hmm. Along with this, we're also having active slots. Okay, constructor accepts max concurrent slots. Okay, so this dot hashtag max concurrent slots equals to max concurrent slots we have been created. Okay, done for so far. Understood. Okay, understanding properly. We have a public method. Public method is a run batch, batch, which has a task array, and this is a sync. Okay, got it. And this method should iterate through a collection of resilient tasks. This method should iterate through a collection of recycle. Uh, these wordings and these sentences like we don't easily compile, and it's a little bit hard to understand also. What is saying, let's understand. The method should iterate through a collection of a resilient task. Collection, where does it the collection, man? I didn't see any collection here. Uh, let's move next. Resource guard. It must ensure that a number of simultaneously running tasks never break the max concurrent slot boundary. If the slot ceiling is hit, the engine must wait or stagger the execution hint process them in chunks. Mm, First of all, I just want to understand what does this mean. The method should iterate through a collection of recycling tasks. This is a recycle. Oh, okay. They are connected. Got it. Actually, this constructor function and this is connected. Mm-mm-mm. This method should iterate through a collection of resilient task instances. But how? Mm, take your time combining elements. Okay, wait just a second. Mm. How does it possible, man? Little bit confused here. This two questions. First is the constructor functions. We have been created with using the constructor function, which is a ES5 module of the JavaScript, and this is class version is ES6 version of a JavaScript. So here we try to merge the both of the concept and working with the to create a resilient distribute task scheduler engine. So we are very close about to finish it. Let's just understand what does this mean. We are stuck here. This method should iterate through a collection of resilient task instances. Task instances. We didn't create a task instances, right? Mm, we didn't do anything yet. Task name, task array. So this is a task array. What we will be getting. So how do we proceed that? Oh, buddy, think little deeply. How we can pass. Okay, so we have a task array, right? We have to say iterate. We will use a map. We have a map here. const data equals to this. We have this thing, right? Task array should iterate through instance of recycling task. Recycling task API callback. Here, what we have been created. Does we play with the API callback? No, I didn't see. Recycling task instances. We will get a callback, right? Some kind of. Let's just assume and work. Task array. How we are supposed to get a task array, right? For now, let's just call this only for now and wait. Here we are putting the async. Okay, so let's just put wait for await. Last instances, I think so. This will be work. The resource guard is it ensures that a number of simultaneously running tasks never breaks the max concurrent slot. Okay, so how we're supposed to do this? It must ensure that the number of simultaneously running tasks. Number of simultaneously running tasks. How do we get a running task simultaneously here? Uh, Max concurrent slots. Mm, my mind is got blank for now. Mm, Actually, these are the complicated things, and I'm also don't know how to do this. Let's ask AI for a hint. Okay, so we have done our solution so far. I need some hint to complete it because currently blank about it. Don't give solution now. Let me try to figure out with your hint. Okay, so we will try because for now we didn't understand what does this means. You have built a very solid structure base here. Your constructor functions, mapping, modern class layout, initialization are exactly what they need to be. Okay, the hint is this and recursion fixes. Okay, recyclant await call cb. So where does cb come from after attempt 1? Stay. Okay, this loses the context. Okay. Mm, hmm. Yeah, really blanked out actually. Okay, yeah. Here we have to use this dot execute. I think so. I don't know. The issue your constructor function already saves your callback into a memory for line number 11. There, execute method. Okay, this dot API method at all. You can read it directly using the API callback. Uh, and to Sorry, we didn't get. We need the solutions. Okay. We haven't done this. Uh, this is the core system design puzzle you currently have. Launches all simultaneously in parallel. It completes bypass max current boundary limit. If you pass the 100 tasks at 100, will be fire at once, will be crash your thread pool. Okay. Approach the chunking gate. Okay. Chunking strategy or approach be dynamic queue workers. Okay, these are the most advanced concept that we have seen now. Uh, with your hint totally blank. Teach me in ELA5 example about this question with solution and explain why it is so. Because we are totally blank. It's happened many times when we observe and face some hard questions. We face this kind of issue because we didn't know, we didn't practice this kind of a stuff anymore. So we have been actually looked a next level question. So it is completely okay to feel blank. Distributed task scheduling is a complex concept. Yeah, it's a very complex concept that I faced till my journey. So like this concept, rarely facing, working with it, but most of the time helping with the agent, and so skipping this type of concept. But now we are supposed to practice it and conquering it. So now we have to understand and increase our capability to understand the more complexity of the things, so we can become a good and an ideal software engineer, because our main target is to understand and become a good software engineer. Okay. It is completely okay to feel the blank. Distributed task scheduling is a complex concept. Let's break this down into a simple real world story first, and then we look up to exact code solution. Okay, let's just break down the concept. Uh, the ice cream shop. Okay, imagine you run an ice cream shop that has exactly two serving counters. Okay, let's assume it with the Excel I draw. Okay, so let's have a new thing from side. Okay, for let's just squeeze. Yeah, we are having this thing. Let's create a form. Yeah, here we will be practicing. Okay, let's just understand how we are going to do. Okay, that's a fine. It has a back option. Yeah, so we have this thing. Okay, got it. uh I imagine you have an ice cream shop. Okay, we have an ice cream shop. This is ice cream shop. Okay, great. Exactly two serving counters. So suppose we are serving counters from here, and also we have another counter is here. Max concurrent slot is two. If a customer five arrives, only two can be served at the same time, and rest must be wake. Okay. So here one, two, three, and either one, two. Okay. So like this, these are the customers. Recycler. Okay. Resilient task. Each customer ordered a complicated ice cream. Sometimes the ice cream machine jams or error failure. Okay, ice cream machines can be error failure. Patient rule. Patience rule, not patient rule. It's about the patience rule. Exponential back off. If the machine jams on a customers, the server doesn't give up instantly. Okay. Suppose this machine is jam. Let's create. Okay, not like that's not a good idea. Let's go with a check. This machine is jam. Okay, this machine is jam here. So what we have to understand, on a customer, the server doesn't give up instantly. Okay, They fix the machine, but the customer will wait for 2 seconds. Uh, Customer is waiting for 2 seconds. Okay. Let's just um, like this. Uh, what we can do is also here is like this. Okay. Customer is waiting for 2 seconds. Okay, understood. If it jams again, they make them wait for 4 seconds, then 8 seconds. It's failed too many times. The customer leaves the max at exit. Okay, the store manager, which is the task scheduler, manage the monitors, the two counters. When one counters become free because a customer successfully got their ice cream or left, the manager waves the next customer from the waiting line forward. Okay, so what it will be do is taking this customer. Just a second. We have a color changer somewhat. Uh, Not like this. Let's take this and here. So what we will do is taking this customer to here because this machine is free, right? Yeah, they will be taking if this is creating an issue, so they don't have to wait for too much long time. It will be retry, there's no doubt, but we don't have to waste their time. So we will be taking there and go to the first machine. Okay, the code solutions exactly. Okay, let's just see how it's work. Here is our exact system work. Prototype layer is silent task. Okay, let's go back to our code. Wait ms that we have been done. Okay, that's a great thing that we have very first worked. So here this is our function. Okay, tracks failure here it will be count. Okay, this is a constructor function we have worked. Okay, we attach the execution engine. What we have to do is the function, it doesn't have any callback function or any parameter. Try const result API this dot API call back. Okay, we have used this dot API callback here. If the result is there, which will be return the success. If it is not, then error. It will be count. Okay, after count, inside there only we will check if the count attempt dot count is greater than max dot retries and return the status dot failed and error. Okay, got it. After that, it also check back of delay. Does we have a back of delay something? No. Okay, this is 1000 multiplied by max dot pi and this dot count -1. Okay, console the back of retry, back of delay. Okay, back of delay it will be seconds, and after the wait of back of delay, so whatever the value comes here, so it will be passing to this here back of layer and back of delay will be, but how? Okay, this data will be pass here wait and this wait will be work. Okay, after this we will be return await this dot execute. Okay, this dot execute will be called. Okay, we are okay, we are going to little correct version, we are thinking correctly, but understood. And the class here tasks schedule engine, how it works. Okay, task scheduler, max concurrent slot. Okay, constructor we have active slot, we don't have a active slot here. Okay, this dot max concurrent slot async run batch. Okay, it has a result array. Okay, actually this is a too much high level coding because we didn't practice this kind of a stuff. We have to practice and master it because this kind of a stuff is the actual coding level which we get a high level pay for this because we understood. For now we are able to decode this, but we are unable to write this kind of a code. Uh, Although the AI is working so fast because we are working so inefficiently, I will tell. Okay. Currently, our coding is so much behind from it, but we have to understand it also. So here, understand the worker functions act like a single serving counter. Okay. Queue dot length. Okay, here the task dot array. Task dot array will be task array will get, and here we are already destructuring it task array in a queue. After that, we are passing a worker async percussion. Okay, while queue dot length is queue is a data structure. All right. Q dot shift pulling the next task here. Okay, Q dot shift will be called the first element of the data. So first element here, and after that we will be execute and result dot push, and like this here pull also. Okay, it's actually the toughest thing that we haven't seen here. No issue. We understood, and we will be try to solve this by own. First of all, we will try to execute with our notebooks, and I recommend also you to uh, do with questions like this in a note and pen, so understand very carefully and then start coding. So yeah, that's it for now. We will be also stopping here because the session is not too much heavy load, and we will be coming back tomorrow with some this kind of questions and practice more about it. Also share your questions with us in our community section or in the comment section. We will love to see and love to solve like this more complicated questions and queries. Okay, that's it for now. Meet you in the next session. Have a nice day. Good night. Radhe Radhe. Okay, can I do this thing? Yeah, I can do this thing.